Good afternoon, good morning, wherever you are. Thank you so much for joining us today. We will be doing a webinar on a very interesting topic called supply chain attack. Now, supply chain attack is when you get attacked on a third-party component that you install as part of your application, and it could be anything, right? So, without further ado, let me just introduce myself. So, I am Phani. I head marketing at Indusface, and today's speaker we have Vivek Gopalan, who is the VP of Products at Indusface. So, Vivek heads the whole product management function at Indusface, and he specializes in the security domain. So having spent close to 8 years at Indusface, even prior to that, he specialized in endpoint security by working in a company called Dhruva. So he has also been an entrepreneur in the past. So just a brief introduction on Indusface. So we are an application security company. We have 150 plus employees across 5 offices. And more importantly, we are trusted by 5,000 plus customers across 95 countries to secure their websites, APIs, and mobile applications. So we have 3 application security platforms. So today's session will mostly talk about Aptrana application protection because client-side protection is part of that. Apart from that, we also have a risk assessment platform or an external attack surface management and discovery platform in Indusface VAS. And we also resell SSL certificates. Coming to compliance, no matter where you are or what your compliance needs are, we meet them. If you have any questions on compliance, please reach out to us. Now, coming to recognitions, over the years, we've been receiving many awards. A couple of awards that we are extremely proud of are the Gartner Peer Insights Customer Choice badge that we've received 3 years in a row. And we are the only one, I repeat, we are the only one with 100% customer recommendation on the Gartner Peer Insights platform. So along with enterprise, we do well on the SMB segment as well, and we are a leader on G2. And users love us. We also have a number of badges like best ROI, best support, and so on. This we've already covered. So we have 5,000 plus customers across 95 countries. This is just a small representative sample of all the industry verticals or the that we serve. So should you need any references when you want to get started with our platforms, please reach out to us and we would be able to give you at least one reference in the industry that you operate in. So we've already discussed about this. So this is where we are on the top right. And even on the top right, as mentioned before, we are the only ones with 100% customer recommendation rating on the platform. And we've maintained that for 3 years now. So that said, we also publish a lot of detailed research on on the application attacks that we block. So contrary to popular expectations, large enterprises are not the only ones who get targeted by these attacks. So incidentally, we just published this report today where we analyzed what kind of threat vectors attack SMEs versus enterprises. The data is very surprising and a very good read for all of you on the call. So this just got published today in a leading newspaper in India. We have the complete report on indusface.com/reports. So please go there and download this. That said, now we come to the core topic. So this is where we talk about what supply chain attacks are, what challenges you face with supply chain attacks, how to prevent them, and more importantly, why are supply chain attacks important? Even if you don't get attacked, there are certain compliances like the PCI DSS 4.0 that mandate that you need to have some sort of a web browser based protection. Now, Vivek will discuss all of this over the call. So over to you, Vivek. So I'm stopping my screen share. Over to you, Vivek. Vivek, you're on mute.
Thanks, Phani. Thanks for the wonderful introduction. Let me know if you can see my screen.
Yeah.
Okay, great. Thank you, everyone. Thanks for joining in. So as Phani pointed out, we have a packed agenda for today. So let's get started without any delay. So let me start by talking about what is a supply chain attacks. Phani did give you a brief about this. So supply chain attack is essentially an attack on your third-party components to gain access to your systems or applications, right? So what do I mean by this? It means like your application is not isolated, right? It's not only the code that you are writing. There could be components that is integrated into yours. There could be open source components. There could be various JavaScripts that's loading as you load this application. It could be an HubSpot.js. There could be an Analytics.js, Heap.js. There could be even for credit card management, you would use Stripe. Again, Stripe would give a JS. So you are integrating a lot of third-party components as part of your application. Now, attackers, instead of attacking your application directly, they could look at the weaknesses in these third-party components, exploit those weaknesses, and in turn gain access to your systems, applications, or data that is behind your applications, right? So that's eventually what we call as a supply chain attack. So why is that important, right? The supply chain attack, as we see it, is ever increasing. Gartner has predicted that by 2025, nearly 50% of your 50% of the organizations will see some form of supply chain attack. One of the recent studies done across 350 organizations in US and Canada, nearly 90% of them said that they had seen some form of supply chain attack in the last 1 year. And even in the last 7 to 8 months, another study says that there were nearly 200,000 attacks, right? So this is widespread. It is commonly increasing. And that is why even in the newer PCI compliances, it is mandatory to have protection against this. I'll talk about this as we go further. But what is very important is this is widespread and it is ever growing. So what are the common types of supply chain attacks? So I did talk about it as a compromise in your third-party components, but the compromise can be in various ways, right? It could be because there is a vulnerability in your third-party component. For example, you have integrated an open source component. Say you have a common example is the log4j attack that was seen, right? So there was a log4j logging component which was integrated in all the Java applications, and because that third-party component was compromised or it had vulnerabilities, all your applications became vulnerable. That's a common example around a supply chain attack, right? Now this vulnerability could have been exploited and causing issues with your organization. Similarly, there could be issues around passwords that you have been using, right? So every person, no matter how you train them, they use the same password across applications. So because of various vulnerabilities or various reasons, these password could have been compromised in a third-party application. There is hundreds and thousands of leaked databases that is available in the dark web. So these could be used to gain access to your application and then get to data that a hacker should not have access to. Your application could be hosted in AWS, or it could be hosted in any cloud service provider. And one of the common exploits around this is the misconfiguration in this, right? So you have misconfigured your database, you have misconfigured your S3 buckets. That is an open S3 bucket, data gets leaked. there's privilege escalations happening. All these things can happen because of vulnerabilities that are there in the infrastructure that gets exploited. All these are examples of supply chain attack. But one of the most common example of supply chain attack is the browser-based attacks, which is where as your application, you are using third-party components, you are loading heaps.js, you are loading Stripe.js, you are using some other analytics, and those JSs are loaded. You are not aware of these JSs. It is getting loaded. Your application team has installed it. As a security team, you have very little visibility towards it. Those JSs are there, lying around. As any client user opens your site, those JSs automatically run in your browser. Now the attack here is essentially you are not attacked. The third-party component is attacked. The third-party server is attacked, and there either the whatever J is getting loaded is compromised. They add a malicious code into that, and using that from the client side, whatever your data is, your end user is adding to your application in the browser, those data could be captured and used by the hackers. That is the common form of attack, which is the browser-based attack. So these are the common types of supply chain attacks that is very prevalent. So such attacks have been common no matter how big the organization is, big or small, everybody is prone to these attacks. I have given examples of large enterprises because that is what makes the news. But as Phani pointed out, it doesn't mean that only the bigger organizations see these attacks. All companies of various sizes see these attacks. The polyfill supply chain attack you might have heard about, because of the compromise in that JavaScript, users were taken to compromised websites. In case of Airbus, a third-party company who had access to their database, Turkish airline company, their employees' passwords were compromised, and because of which hackers were able to get access to the Airbus data. Microsoft, again, big organization, again, they were compromised because of the vulnerability found in the J Factory artifact. Even Norton was not spared. They being a security company, they again were compromised because of the third-party supply chain attack stories. So again, the thing that you should take away from this is that big or small, everybody is prone to these attacks, and you should be thinking about how your organization is protected against such type of attacks. So before we go forward, a quick question around this. How confident are you in addressing such type of attacks? The poll will start now. I will give you a couple of seconds to answer the poll question. Essentially, we just want to see if you are thinking about this and is there any protection or the policies around this that you have already implemented. We'll just close the poll now. Yeah, Manju, you can close it. Publish the results, please. Great. So about 60% of you have said that you are somewhat confident, which is great. About 10% are non-confident and 20 are highly confident, which eventually means you have some kind of protection in place. But that said, let's see how we can also help you around this, right? So before we get into that, a bit more details around the challenges that are there around the supply chain attack. The biggest challenge that we see around the supply chain attack is the visibility aspect of it, right? As a security team, you know your inventory, you know what are your applications, you take necessary controls, put in necessary controls to protect those applications and the likes. But you do not have much of a control on what is happening in your third-party components that you are using. A new update in your third-party component could be vulnerable, and that eventually means your application is vulnerable. And the biggest challenges around this is many times these vulnerabilities just go unnoticed, right? A component gets changed, you are not even aware of it. Life goes on. Only when an attack happens, only when a compromise has happened, you even get to know about these things. Depending on how your security management solutions are, they may be able to support virtual patching or patching around vulnerabilities that are in the third-party component, they might not. But if they don't, and you don't have control over these components, so you don't have any control over the timelines of the vulnerable when these vulnerabilities is fixed or not. If your application needs to be live, these components will also be exposed and the vulnerabilities will also be exposed. So these are the biggest challenges that we see when it comes to addressing the supply chain attack. So now just switching gears and seeing how we in Aptana can help you protect it. We as a comprehensive web application and API protection solution with a risk-based approach, we have protection to majority of these attacks already, right? So if there is an open source vulnerability, we have a scanner, we detect those vulnerabilities, we patch them quickly, and we also help patching vulnerabilities in the open source components also. For example, when the log4j vulnerability was there, within a couple of days, we had all our customers protected against these vulnerabilities, even though their backend application was exposed towards it. Protection against leaked passwords are again available by default. We have various account takeover protection controls, which will help you protect against credential stuffing attacks and protection against exploits using leaked passwords. If you have misconfiguration in your infrastructure level, when you have onboarded your application behind Aptana, we become the front-end facing. So essentially, your application's IP is resolved to us, and since our infrastructure is secure, your misconfigurations do not get exposed. So all these things are getting protected by default. Now the problem is around the browser-based attack, and which is what we will be concentrating for the rest of the webinar, where there is a JS component that is compromised at the browser level, and you are not even aware of it. So to protect against this, what you need is what we call as the client-side protection. So now let's see how this works, right? So just let's assume I am your end user, right? And I'm trying to access your application. I load your application. Your application in turn is using a trusted JS, which is loaded from a third-party server. And as part of the application, I need to give your credit card details. I give the credit card details. Your application uses the credit card details. And only the analytics, whatever analytics you're collecting, which needs to be sent to a third-party server, that is sent. This is an ideal scenario. Just to help you connect, let me show how this thing works, right? So this is a demo site, which is behind the login page. So I'm just logging into this. As I log in, you can see there is an analytics.js that is loaded. This is a legitimate this thing. It is going to vendor.qa.aptana.com. From this, the JS has been loaded. So when I give one credit card detail here, pretty much your application uses it for what it is entitled to do, and it is not doing anything else, right? The data is so saved, all well and good. This is the ideal scenario that is happening. Now, as a security owner or as your even application owner, you're not aware that what is happening in this analytics JS. You know that your application team wants to use this. You have approved it all and good. You know this is the analytics JS that needs to be incorporated into this. Now, what will happen is your hacker, he would go ahead and exploit the vulnerability in the third-party organization using various means, probably exploiting a vulnerability, doing social engineering, whatever means possible. He will end up injecting a malicious JavaScript in the third-party server. You are not in line with this, right? You don't have any visibility on this. You don't know the vendor's infrastructure. You have no control over the security of this. So now, as an end user, when I try to access your website, what will happen? The malicious JavaScript will also be loaded, right? So this is And at this point, this is a browser, right? I'll show you how that works. It's a browser. It's not in line with any security solutions that you have in place, even the WAF or even after a WAF. We will not be aware that the malicious JS has been loaded, right? So now what happens? I give a credit card detail. Normally the usual analytics will be sent to the third-party server, but this malicious JS would also capture these credit card details and send it to the hacker. So eventually the data that should reside only within your application is now compromised and the hacker has access towards it. This is essentially is a supply chain attack. It's a browser-based supply chain attack. So let's see that happening, right? So this is a similar site, but it is loading the JS from a compromised third-party server. So I am loading this. I'm logging it here. So now you see, this is a network tab, right? Normally you won't see this, but I've opened a network tab for the demo purpose. If you can see, similar to the other JSs, there is one more JS that is added, which is malicious in nature, which is the stealer.js. Now, if you look at the stealer.js, this is actually sending a data. It is essentially sending data to, is requesting and sending data to sniffer.test.com, right? So what I've done is I've written an small application which would capture the details sent to that server. So currently there's no credit card details, but if I give data, right, and I give, and just to for hack 0127.122 and save it, the behavior to the end user is the same like what you saw in an uncompromised website. But this stealer.js has also captured this data and sent it to here. So if you look at this, the hacker has got your data now, right? This is the supply chain attack that we are talking about. And for this, what you need is a client-side protection. That is a protection that works at the browser level. So how does this
Okay. This one is like a single record data breach every time someone enters a password. I mean the credit card details, right?
Yes, any user who comes and tries here, and this is your end user, right? End application, right? And this application is loading the stealer.js. So any user who comes and gives any data here, in this case, I just have one page. There could be multiple pages, multiple users providing data. All these data could be captured by the stealer.js and sent to the compromised server. So that's essentially the problem with client-side attack. And if you could see, for a normal user, nothing has changed, right? The behavior is the same, the application looks the same, everything is the same. So they won't be aware that there is a compromise happening. As a security team, because it is a third-party component that has a compromise, the security team is also not aware of it, but the hacker has got the data. That is essentially the crux of it, right? So how do we protect against this, right? So what we do as part of our protection layer, right? So what we do is, this is your normal behavior, right? So when you get the site, you expected from the third-party server only trusted.js to come in, right? You did not expect the malicious code to come in. So what we do is, when you onboard your application behind us, we learn this behavior, right? We learn this behavior, we show it to you. As a security team, you would be able to verify this and approve it. Once you have approved it, then anytime any of your end users loads your application, we will be monitoring the client for this end user behavior. But instead of that, if say the behavior is like this, where a malicious script is loaded, what we will do is we will block those. We'll block that malicious JS. So only the trusted JS will come. So even if your third-party server is compromised, that third-party JS will not be loaded in the browser. when the application loads. So only the trusted JS would be loaded and the life will move on, right? You will not be, nobody, the data is not compromised, you will not, nothing will happen, and life moves seamlessly, right? That is the power of the client-side protection that we bring, which will help you protect against the browser-based attacks. Let me show that in the live example, right? So now this is a site, the same site, which is protected behind Akrana with the client-side protection enabled, right? So I have my client-side protection enabled. I'm logging in. Now, if you can see the same Stealer.js, because I'm loading the data from the same third-party server, that JS is now blocked because it is not part of the known behavior. It is not part of the JS that which was allowed to be loaded. It is blocked. Now I can give a new credit card detail 222421222, right? And I'll say Vivek not hacked 012228 and 1, right? I have said the details. Because the Stealer.js is not loading, the data will not come here at all, right? Only the old data is there. So this is how the protection works. Protection works seamlessly without any compromise of your usual behavior, but also protecting you against these unknown third-party attacks that is happening at the browser level without you being even aware of it. So let me show you how all these things tie together in the portal. So this is my client portal. So I have those applications onboarded behind me. So this is the store.indusecure.com. This is actually not protected. So I've just onboarded that. I have it in the learning mode. So if you can see, I would have identified that this is the domain from which there is external JavaScript that is being onboarded. This learning is all the time. And you can also come here, see the third-party references, right? This analytics.js can also load other JSs as part of your as part of its working. So all these things are clear. Now you know that this is all good. As a security practitioner, you can cross-verify this with your application team as needed. You can see that, hey, is this the expected behavior? Once it is expected behavior, you can go ahead and do an approve and save, right? And you can move it to protect only mode. So once you do the protect only mode, your protection starts, right? This eventually means that like any other thing, the protection would have started. So now I have another site here. It is already onboarded. There is protection already happening. There's bot protection. Similarly, there is a browser protection. So this is my protected site, right? This is the my card, which is behind Aptrana, which is already protected. If you can see, it is the same behavior. You have already allowed it as before, and the protection has started. Now, because the third-party component, this one, right, this JS has been compromised, it cannot, because the analytic JS has compromised and it is loading one more malicious JS, which is the sneaker.js, what will happen is you will get an alert saying that there has been a compromise in the analytics that you have allowed already. And if you go and see the reference chain, we would have automatically blocked the sniffer, right? The sniffer which is being loaded already, the stealer.js, that is automatically blocked. So when the user tries to access this, it will be automatically blocked and the protection will work seamlessly for you without any need for you to take any actions. The only thing is because something has changed, we have also alerted you. You can look at this, talk to your application team, see if that is a necessary change that has happened, or if it is a compromise. And if it is a compromise, you can go and work around and see how do I work around that. And during all this time, your end user is never compromised. The data is always protected. The client, the browser is completely protected. This is how seamlessly the things would work if you have Aptana's client-side protection with you. So that's pretty much what I wanted to cover as part of my demo. So with this, we provide an holistic protection against the supply chain attack, which is just the browser-based attack, which I have shown with an example on how we will protect against these attacks. So as a best practice, right, what you need to do is you need to have inventory of all your applications. You need to have inventory of all the third-party components that are used as part of your applications. Have periodic mechanisms to scan these components if it is part of your application. Uh, have those vulnerability checked, have those patched, and if there are any third-party components loaded at the browser level, have the inventory of those also and have it approved, right? Have the workflows approved so that you have a complete posture of what is happening. And then when there is a deviation, you are aware of it and the protection starts with solution like Aptana. The protection is very seamless as I have demonstrated. So this is one is obviously every security needs to be done just for it because you need to protect your applications and the data and the trust your customers provide on you. But that said, there are always compliance that drives the adoption, right? And one of those compliances that drives the browser-based protection is the PCI DSS compliance. The 4.0, which is a newer compliance, which now if you are in the older version and you have to renew your PCI certificate, you have to renew it at 4.0. And one of the clauses of 4.0 is to have visibility around this, right? So it says that you should have a method to confirm what are the scripts that is being loaded in your browser. Should have the way to monitor the integrity of this. You should have a workflow to see what is getting loaded, what is not getting loaded, and if anything changes, be able to react towards it. And all these things is protected by Aptana's client-side protection by default, as I had demonstrated. As you onboard your application, you get a visibility on all the JavaScripts we learn, and we continuously learn on the behavior of your application at the browser level. We give you the list of all the inventories across, including the secondary level inventories that is being loaded from the primary inventories. You can look at this, you can approve it, and once that has been approved, we constantly monitor for the integrity of those approved scripts. If those integrity gets changed, you get immediate alerts, and also the protection starts seamlessly without any intervention from you. So if you have signed up for Aptana's client-side protection, you automatically comply for the PCI DSS 6.4.3 requirements. A quick poll question: would you want to have a free trial for Aptana WAP? The poll will start now. Okay, we'll have this poll open, but I will continue with my rest of the slides. So in summary, right, what do we do as part of a client-side protection? As you onboard your site, we would start the learning mode. We will identify all the inventories, all the JavaScripts. We will say, hey, from these domains, these JavaScripts are loaded. These JavaScripts are in turn loading these JavaScripts from these domains. All these information are provided in a single view in an easy manner to you. You can look at this. You can see whether this workflow is good and approve this, right? That is the only job that you have to do. Once that is done, the automatic threat alert monitoring will start. If there is anything changes in your in the third-party components, you will be automatically alerted. The protection will start by from day zero. You can also get our help of our famed managed service team, who is a 24/7 SOC team, who will also be constantly monitoring your alerts, the threats, the ever-changing threats, and you can reach out to them for any help as you need it. With this, you get a comprehensive protection for your browser-based attacks. Any supply chain attacks like the Magecart attack and those likes, you don't need to worry about this anymore. And last but not least, with this, the PCI DSS requirements around 6.4.3 and 11.6.1 was automatically taken care of with Aptrano. So with that, I want to leave you with the final slide, which is just talking about our web platform. So we are the only vendors who provide a comprehensive web application and API protection platform for you guys. We start with external asset discovery. So if you have any external assets as a security team, if you're not aware of, we give a discovery solution which will look at the internet, try and find out all the assets that are part of your organization. These assets may be web assets, API hosts, or mobile applications. We identify those assets and give you those lists. And from those assets, you could decide which needs protection. And as you onboard those sites for protection, two things happen simultaneously. The first thing is we do the risk detection. Our scan automatically starts, which will help you identify the vulnerabilities that are part of the application, which would it could be APIs, mobile apps, or web applications. No matter what, we'll help you identify the risk of those applications. And simultaneously, the protection also starts. The protection is comprehensive, and we are the only vendors who give protection from day zero in block mode. We support this also with our managed service team, and hence we are able to do false positive monitoring and ensure that all your applications remain in block mode. 100% of our applications remain in block mode all the time. We have also released Swift Comply, where if you could, with a single click of a button, get a clean report within 72 hours. This is a clean scan report. So if there are any vulnerabilities found during the scanning, we will patch it at the virtual layer in the WAF, run a scan through the WAF, and then give a clean report. This clean report can come in handy in multiple ways. You could use it for your compliance needs or any security needs you have. Also, say you have a new release that is happening and you have found 10 vulnerabilities. The security team, instead of becoming a blocker, saying that, hey, this vulnerability has to be fixed in code, you could use our Swift Comply, fix those vulnerabilities, add the virtual patch, have a clean report, have the security and the peace of mind that your application is protected, and let the release go, right? So that's the beauty of our comprehensive web platform. I sincerely urge you to test this out along with our client-side protection that I had demonstrated. With that, we come to the end of our webinar. We are open for questions.
Thank you, Vivek. So we have a question. So it is like, for every request, will it check the site?
So yes, I mean, so what happens is once this is enabled, there is a script, there is a protection that is happening at the browser level. So as your user uses your application, we will constantly monitor for what all the JSs are loaded as part of the application at the browser level, right? And when it is abnormal or when it is not part of the approved behavior, those would be automatically alerted and blocked. So that's essentially. So yes, it will be working for all the end users, all the browsers.
Okay, any other questions? You have the Q&A button at the bottom of the screen. Will it monitor only .js or it will also monitor other?
At this point, we are monitoring the JS and other scripts. We will be extending it to further third-party links and all those things also in future. At this point, mostly we are concentrating on the major use case that happens at the browser level.
Any other questions? Do you do server-side protection as well?
Of course, right? With a web protection, that's what we do. The server-side protection is what I explained in this, right? Everything, our web platform is very comprehensive and it protects your server applications that is running in your server through our web platform. And now we have also added our client-side protection as part of this wheel, essentially protecting both your browsers and the servers.
So essentially, just to further clarify, I think Vivek, you had that slide where we had all four types of supply chain attacks, right? So uh, see, supply chain attack can happen in multiple places. Depending, let's say if you use an open source software or server like, Apache components or even a framework like Java or PHP. So it can happen at multiple places. So what happens on the server is protected by the WAP, and what happens on the browser is a browser based attack, and that is what we protect through the client side protection feature of the WAP. That is what we do. How do we access? Yeah, so all the participants will get a recording to this session. So what is PCI DSS compliance? Now this one, PCI DSS compliance is if you process credit cards on your website, you need to be PCI compliant.
Yeah, I mean, essentially that's what it is, right? If you are a vendor who are either processing credit card, you're storing credit card, or even you're a vendor who are supplying to some other vendor, some other your customers who are getting your credit card data. Uh, in either of these cases, because you are in line again the supply chain, right? If you are providing any components uh, to your customers who are storing processing credit card data, then again you need to be PCI compliant. These are standard mandatory compliances that all these banks and financial organizations or POS solutions should adhere to.
In fact, even if you read RBI guidelines, they say wherever you process credit cards, you need to be compliant with PCI. So it's a very, very good framework to protect all your credit card information. Now the next question is who manages PCI? So PCI, the full form is payment card industry, if I'm not wrong. Right, so this one has been established by Visa, MasterCard, and all the payment card providers. So it's a non-profit that regulates the usage of credit cards. So all the card people who issue credit cards are part of these members. By issuing, I don't mean banks. The essentially the credit card providers like Visa, MasterCard, Amex, and so on. Any website where we will fill credit card? Yes. So any website uh, that where you add credit cards, right? So in fact, they display saying that, okay, PCI certified. So there is a badge that they display on the top, whether it is, Amazon, any of the e-commerce platforms that you use. So yeah, don't enter your credit card if they say that, they are not PCI compliant. Okay, any other questions? Okay, looks like we are already on time, and we finished right on time. Thank you so much, everyone, for joining us today, and uh, you know on the session on supply chain attacks. We will send you the recording, and in case you have any need for protecting your websites, applications, or mobile apps, please reach out to us, and then we'll get back to you. Thank you so much. Have a great rest of the day. Bye bye.
Thank you.